The educational content for this session will introduce 4 object items for setting permissions, and the educational content will proceed in the order of introducing policies for control purposes in NAC. The second training topic in this chapter is objects. Objects can be created and categorized into network, service, time, and permission types. Network objects can be created based on IP and FQDN. Service objects can be created using TCP, UDP, and ICMP. Time objects allow for specification by date, time, and day. Finally, permission objects combine previously defined network, service, and time objects into a single entity. Each object can be used as a condition in node groups. Permission objects can also be assigned to control policies to establish network access control policies for user endpoints. Network objects are created in the following order. First, enter the basic information such as ID and description. Next, include other network objects in the group. Or finally, enter the network address of the target to be controlled. ID is a required field, and at least one of the following must be set to create the object. Specify and child network object. Specify and condition. We will create a network object with the network address 172.29.114.0 and a 32-bit subnet. Select the IP and netmask option. Set the appropriate IP address and subnet mask, and then click the Create button. After that, click Apply at the top to complete the creation process. Service objects are created in the following order. First, enter the basic information such as ID and description. Next, include other service objects in the group. Or finally, specify the protocol and port for the service. ID is a required field, and at least one of the following must be set to create the object. Specify and child service object. Specify and condition. We will create a service object with the protocol TCP and service ports 80 and 443. Select the TCP option, set the appropriate service ports, and then click the Create button. After that, click Apply at the top to complete the creation process. Time objects are created in the following order. First, enter the basic information such as ID and description. Next, include other time objects in the group. Or finally, specify the date, time, or day. ID is a required field, and at least one of the following must be set to create the object. Specify and child time object. Specify and condition. We will create a time object that represents 9 a.m. to 6 p.m. daily. Select the date, time, day option, set the appropriate time range, and then click the Create button. After that, click Apply at the top to complete the creation process. The final permission object is created in the following order. First, enter the basic information such as ID and description. Next, specify the network object, followed by the service object and the time object. ID, network object, service object, and time object are all required fields. If any of these are not set, the permission object cannot be created. We will create a permission object to allow TCP 80 and 443 service ports for the 32-bit network 172.29.102.0 from 9 a.m. to 6 p.m. daily. Select the appropriate conditions and settings through the network object, service object, and time object options, and then click the Create button. After that, click Apply at the top to complete the creation process. The first permission object is created by including a network object, service object, and time object. The second network object can use the FQDN condition. The final training topic in this chapter is policy. There are 7 types of policies that can be configured in Geneon NAC. Node policy defines how to perform user authentication for endpoints. Agent policy, management policy, operates agent plugins through node actions, and configures detection for anomaly definition. Enforcement policy assigns permissions to node groups, enabling network control based on roles. 802.1x policy provides port-based control for authenticated endpoints through radius authentication. Wireless LAN policy manages network access profiles for wireless sensors and endpoints. Windows Update policy manages and applies patches to endpoints with Windows-based OS. External device policy controls external devices connected to endpoints. Compliance policy specifies multiple node groups and determines whether a node is part of the group, representing the result as O or X. Among these, node policy, enforcement policy, 802.1x policy, and compliance policy can operate independently. Wireless LAN policy, Windows Update policy, and external device policy require corresponding agent actions to be assigned to the endpoint for enforcement. NAC policies are divided into 2 categories. Single policies. Only one policy can be applied at a time. Multiple policies. Multiple policies can be applied simultaneously. The following policies are single policies, and only one can be applied to a node. Node policy. Enforcement policy. 802.1x policy. Windows Update policy. The following policies are multiple policies and allow multiple policies to be applied to a node. Wireless LAN policy, device control policy, compliance policy. To apply a single policy to a node, NAC uses an item called priority. When creating a policy, you can specify the priority to ensure that nodes are evaluated sequentially to determine if they meet the policy criteria. Once a node is included in a policy, the policy is applied based on that priority, regardless of subsequent policies. If the policy is modified or new policies are added, the reassignment process is triggered. The policies assigned using this method include node policy, enforcement policy, 802.1x policy. The Windows Update policy does not have a priority. However, it applies as a single policy by assigning a unique update ID to an agent action to perform the policy. The Wireless LAN policy, which allows multiple policies, assigns policies as follows. The Wireless LAN policy can create 2 types of profiles. 1. Client profile. This profile applies directly to endpoints. Policies are applied by selecting and assigning multiple profiles created through agent actions. 2. Access point profile. This profile applies to APs. Policies are enforced by assigning the created policy directly to the AP. The external device policy targets node groups for policy enforcement. When a node is part of multiple node groups, it can have multiple policies applied concurrently. The compliance policy is configured by assigning multiple node groups to the policy. If a node exists in multiple node groups, it will receive and apply multiple policies. Let me explain the first policy part, node policy. The node policy assigns a policy group to specify the target nodes for enforcement. It is created by configuring the following elements: authentication policy, agent policy, management policy, node action, threat detection. Once these settings are completed, the policy is generated. Let me explain the detailed components of the node policy. Authentication policy. This section defines the authentication method for endpoints. You must choose between host authentication or password authentication. If you select password authentication, you can choose one or more methods, including local database, radius, LDAP, POP3, IMAP, SMTP, or webhook. Agent policy. This section configures the functionalities related to the agent. Options include enabling or disabling the agent, setting the agent to launch upon system logon, defining a retention period for inactive agent data, and specifying a custom execution account. Management policy. This section handles node management settings. It includes options to restrict the host names of new nodes and configure the retention period for inactive nodes. Agent action. This assigns predefined agent plugins to nodes. Detailed configuration of agent plugins will be covered in Chapter 5. Anomaly definition. This section assigns and configures thresholds for 11 predefined anomaly event types, recognized by Genian NAC. The authentication policy is a section that is configured when using NAC user authentication. For password authentication, it provides a feature to sequentially check account information across multiple servers, as shown above. Node policy refers to the settings that control how the NAC agent operates. It allows you to configure options such as whether the agent is enabled or disabled, setting a dedicated execution account based on system privileges, automatically deleting agent information if inactive for a certain period, and restricting agent functionality during system logon. Management policy is a setting that manages node-related configurations. It provides features such as restricting host names and deleting nodes that have been down for a specified period. The Node Action section assigns plugins that operate as modules within the NAC agent. Multiple plugins can be assigned to meet the specific objectives of the policy. Details on plugin functionality and configuration will be covered in Chapter 5. Agent. The Anomaly definition section assigns the 11 predefined risk events in NAC. Depending on the event type, you can either define thresholds for flexible usage or utilize the event's built-in detection functionality. The first event in Anomaly definition provides the ability to detect ad hoc networks. The ad hoc network detection event identifies interfaces on the device that are configured to connect to unauthorized networks. The second event in Anomaly definition provides the ability to detect ARP bombs. The ARP bomb detection event identifies devices that send ARP requests exceeding the threshold to a honeypot configured in NAC. The third event in Anomaly definition provides the ability to detect ARP spoofing. The ARP spoofing detection event utilizes a honeypot configured in NAC. It detects requesting devices by identifying discrepancies where the source MAC address in the Ethernet frame differs from the sender MAC address in the ARP request. The fourth event in Anomaly definition offers the capability to detect MAC IP cloning. In this detection process, NAC sends ARP requests. Under normal conditions, a single response is expected. However, if multiple responses are received, it is flagged as a potential risk, identifying MAC IP cloning activity. The fifth event in Anomaly definition offers the capability to detect malware. The malware detection event identifies potential risks if malware is detected on an endpoint through the EDR plugin installed on the device. This feature is only available if an EDR solution is in place. If no EDR product is deployed, this function will not operate. The sixth event in Anomaly definition is port scan detection. The port scan detection event uses a honeypot configured in Genian NAC. If port scanning exceeds a specified threshold, the system detects the device as a potential threat. The seventh event in Anomaly definition is rogue DHCP server detection. This detection event monitors DHCP offer packets. If the DNS information in the DHCP offer differs from the DNS configured on the network sensor, the system identifies the DHCP server as unauthorized and flags it as a potential threat. The eighth event in Anomaly definition is sensor MAC cloning detection. This event detects malicious attempts to assign the same IP and MAC address as the network sensor to another device. When this occurs, the system flags the device as a threat and ensures the network sensor maintains its role without disruption. The ninth event in Anomaly definition is unauthorized service requests. This event uses the NAC honeypot to detect and flag devices that initiate TCP session requests to unrecognized services. When such activity is detected, the system identifies the device as a potential threat. The 10th event in anomaly definition is rogue gateway. This event triggers when the gateway information sent from the agent installed on the endpoint does not match the known or authorized gateway address for the network. If the gateway is unrecognized, the system flags the endpoint as a potential threat. The 11th and final event in anomaly definition is SNMP block request detection. This event leverages SNMP traps to monitor and respond when a block request is triggered based on the MIB data provided by Genian NAC. If an SNMP block request occurs, the endpoint responsible is flagged as a potential threat. Let's create a new node policy. Navigate to the Node Group tab and add the appropriate node group based on your objective. In the Policy Preferences tab, configure the detailed options for Authentication Policy, Agent Policy, and Management Policy. Proceed to the Agent Action tab and add the necessary node actions that align with your goal. In the Anomaly tab, select and add relevant anomaly detection events. Finally, click Apply at the top to complete the creation of the new policy. Now let's move on to the enforcement policy. The enforcement policy assigns node groups to specify which nodes the policy will apply to. It then grants network access by assigning permission objects. Additionally, agent action and redirection actions are configured before finalizing the policy creation. The redirection options consist of 3 items. 1. Configure custom web page CWP for each policy. 2. Enable switch port blocking by configuring integration with switch and SNMP. 3. Use radius COA change of authorization commands to control switch port permissions. The enforcement actions consist of 4 options. 1. Automatically create or configure custom outbound policies on the Windows firewall, applied by NAC. 2. Display a notification pop-up on the endpoint when network access is blocked by NAC, informing the user of the restriction. 3. Enable power control to forcibly shut down the endpoint. 4. Control the network interface on the endpoint, preventing further network access. Let's create a new enforcement policy. Add node groups. Use the Node Group tab to add the appropriate node groups. Add permissions. Use the Permission tab to add the relevant permissions. Configure redirection options. In the Redirection Action tab, configure the detailed options according to the desired settings. Agent Action. Use the Agent Action tab to add the necessary actions. Finally, click Apply at the top to complete the creation process. Let's proceed with the explanation of the third policy, Radius Policy. To use this feature, the NAC Radius server must be properly set up. I'll explain the details as we walk through the policy creation process. Let's create a new Radius policy. The authentication server is the NAC Radius server. The policy targets are specified by grouping based on the Radius attribute values included in the access request packets from the authenticator. There are 16 attribute options that can be set as conditions from the Radius Access Request packets. Select the desired attribute from the 16 available options, set the appropriate conditions, and click the Add button. Once the group is created based on the defined conditions, attributes are assigned to the group members, applying the 8.0 to .1x policy. These attributes are included in the Radius Access Accept packet sent from the authentication server as part of the attribute list. There are 10 assignable attribute options that can be included in the Access Accept packets as part of the attribute list. Configure the desired conditions from the 10 attribute options, set the appropriate values, and then click the Create button. Finally, click Apply at the top to complete the creation process. The fourth policy to be explained is the Wireless LAN policy. The Wireless LAN policy consists of two components that can be configured within a single policy. AP profile and client profile can be configured. The client profile can be used by the agent plugin, such as the Wireless Connection Manager or Wired Connection Manager, depending on the policy. The AP profile, on the other hand, is only applicable when a Genian NAC wireless sensor is deployed. This profile allows for managing the distribution and removal of wireless connection profiles provided by the AP. This enables comprehensive control over wireless environments managed directly by NAC wireless sensors. Let's create a new wireless LAN policy. First, go to the Client Profile menu and configure the profile to match the policy's purpose. Next, navigate to the Wireless LAN Policy menu, and under the Radius Policy and Client Policy sections, set the appropriate conditions and configurations. After that, click the Save button. The newly created Wireless LAN policy can be utilized through Node Actions. For more details, refer to Chapter 5, Node Actions. The fifth policy to discuss is the Windows Update policy. The Windows Update policy can be applied when the OS on the user's device is Windows. This policy allows for the automatic installation of updates categorized as Security, Critical, and Definition for Microsoft products, including Windows Server, Office, and Client OS. Let's create a new Windows Update policy. First, configure the appropriate settings and conditions through the Automatic Update section. Once the desired configuration is set, click the Create button. The newly created Windows Update policy can be utilized through Node Actions. Further details will be covered in Chapter 5, Node Actions. The sixth policy we'll cover is the External Device policy. External Device policy assigns node groups to define the target devices and applies control by configuring blocked devices and exception devices. Blocked and exception devices can be selected from all devices listed in the Windows Device Manager. Let's proceed to create a new External Device policy. First, navigate to the Device Group menu and create a list of devices that will be used for the policy. Next, go to the External Device Policy menu and configure the settings and conditions according to your needs. Then click the Add button. Once the policy is created, click Apply Changes at the top to finalize it. The newly created device control policy can be utilized through Node Actions. For more details, please refer to Chapter 5, Node Actions. The final policy to be explained is the compliance policy. The purpose of this policy is to create node groups related to compliance and display the results. This allows you to assess overall compliance with regulatory requirements. Let's create a new compliance policy. Go to the Conditions section and configure the necessary conditions according to the desired purpose. Once completed, click the Add button. The results for the configured conditions can be checked in the Status and Filter section at the bottom left of the Management menu. One, Wireless LAN Policy, External Device Policy, and Windows Update Policy. These policies cannot be applied independently. They require the use of agent plugins to enforce their rules and configurations on endpoint devices. 2. Enforcement Policy. This policy is responsible for defining network-related blocking rules. 3. Compliance Policy. This policy does not enforce control or restrictions. It is used solely to monitor and display information for compliance purposes. In this session, we introduced 4 object items for setting permissions and introduced policies for control purposes in NAC. Next time, we will introduce the second item of the 4th chapter, WebUI Management.